Hey guys, so today you and I are going to talk about API testing. So let's get into it. So the question in question was, Frederick, how is API testing performed in big organizations like, for example, Google, Facebook, Amazon, etc.? How do they make sure that all new features and existing are working as expected? What are the end-to-end processes and tools which are used, and it, how is it so immaculate? This is an excellent question. It's one of those things where you ask that of a candidate, and depending on their answer, you will figure out if they worked, what level of project size they've ever worked at. Let's see if you can spot my level. So, the first and foremost thing to kind of acknowledge is that when you say API testing, it very much depends on scope. How big is the test going to be? Because if, let's say for the sake of argument, that you have a single monolithic application, then the API testing is fairly straightforward in reality. It gets a lot more complicated if we are going to do something like an end-to-end test, where the basic idea of an end-to-end test is that you actually simulate usage of the live system, ideally as close to production as possible. If you can test in production, that's a very good thing, and there are ways to do that, many different ways. I'll touch on a few. But the problem in, say, a microservices architecture, or a very like a highly coupled microservices architecture, is that you have all these different APIs that need to connect to each other, and anybody who's ever tried to trace the call between different services will know how difficult that can be unless you have a fairly strong understanding of, request tracing or request IDs or something like that, where you can basically follow along all the services in between your call and the end result, which is something that can be very difficult, but there are ways to fix that. So one of the first things to do is of course to invest in unit testing and local, like, testing of the service. The reason why that is so important is because in a very distributed system, such as they have at Google, Facebook, etc., when you have so many services, it's actually very impractical for you to run tests that hit all of those services as part of your test. So it's better for you if you can achieve like just an isolated test where you test all the inbound and outbound connections within your own service, because that way, if you know if that unit, that bubble, if that makes sense, which is actually a term called the test bubble, we'll touch on that as well. If you can just make sure that that piece works, well, then you can feel comfortable sending that out into your network of different services and so forth and so forth. So that's number one. Try to have a very hefty strategy for these sorts of things. Then the next step comes, which is the most important part to get right, in my opinion, at the very least, when you're doing microservices or a very large distributed system, and that is contract testing. Now, you don't have to do contract testing in the sense that you actually there are specific tools like Pact and similar that is very cool, I think, for contract testing. But the basic idea of a contract test is that you have in a distributed system, you have a network protocol, which is usually HTTP, like you connect to the other services in the system through some APIs. Now, the thing, as I said, if you have made sure that your piece of the problem or your piece of the system is working, then the next thing is to make sure that it's compliant with all the connections it might do to other systems. And that's where each system needs to expose some type of open API spec, Swagger file, or whatever you might have, right? Ideally, if it's possible, they should generate clients, API clients for their different consumers. That's very, very good, because then the team that is publishing those clients is basically making sure that, if they make updates on their side, you as the consumer of their services, you're going to get like a ready-made REST client or something like that that you can just consume, and then you don't have to worry so much about versioning and things like that, because breaking changes is a big problem in these sorts of just larger APIs, API structures. So the contract test is basically just a way for you to write a test against some other API and say, hey, as long as you follow this spec and all of these things are true on your side, I'm happy. Then I've tested all the stuff that I care about on my side. And then you allow the other party, which is the provider of the service, to write tests that matches your expectations, and that usually creates a contract file or something. It's sort of like an interface where you just both agree on that if you send this request, this thing will be returned under these circumstances, which is a very powerful thing to invest in. Now, that in of itself is also not exactly enough, because this is now sort of still in theory land, and the live system is the thing that you really want to test. And this is where you could use a few strategies. If you have test environments, things like that, it can be very difficult in a large system to have test environments for all of these services. But something that is a very good thing to look at is to have, well, end-to-end tests, but you can also use more advanced forms of it is end-to-end testing, but more advanced forms of end-to-end testing. So you can have UI-based end-to-end testing, where you actually use the application as a user would, and you observe the outcomes of like the expected behavior of all these services in some type of QA environment. As I said, that's very, very difficult. It's actually, I would say, even impractical in some cases, but it is possible. It's something you might do if you work with not maybe a complete microservices sort of architecture. You can do that as well. It's just it gets very costly very quickly. If you're using maybe a more SOA-oriented type of architecture, it's a little bit easier because you don't have as many moving parts to keep track of, so it becomes a little bit easier to manage, I think, at the very least. But the other thing you can do is that you can use synthetic logging or similar sorts of things, where you record. You have something that lives on the edge, like say a gateway or something like that, that can record the traffic, or a service that's something like that that records the traffic that is being used as people are actually using the system, and then you can store those recordings and actually run those recordings as part of tests, just to give you some insights into, like, is the system still behaving, etc., etc. And that's also extremely useful, because those recordings, that's where you can create a test bubble as well, where you can actually isolate a group of services that are sort of interconnected with each other. You can make sure that when they call to external services, you can actually use the responses from previous runs to simulate the response as it would have looked under the same sort of circumstances, and just make sure that those things work together. Finally, the one that I think is the nicest, the best one in my opinion at the very least, when you have, and this is something that Google, for example, does, which I think is really nice, that's going to be canary releases and feature flagging. Now, the basic idea of that is that you ship a new feature into the live environment under what we call a feature flag. So before you remove old functionality, for example, if you're going to update something, you create a new instance of that functionality. You send that out into cyberspace. You can do blue-green type of deployments if you want to as well. But the basic idea is that you allow a little part of the traffic, maybe a few people, to go through those new services and just see if it actually works. And when you see that, yeah, it's stable, there's no errors, anything like that, you add more people and more people until all the people are going through the new services, and then you can deprecate the old code and remove it. When you do Android stuff or things like that, for example, feature flagging is a big thing, where you might ship a version 2 of a new feature, but you still have version 1 ready, and then you flip a flag, which means that when the users are using their apps or something like that, they're using the new functionality. But if it breaks, or if you see that there's something that's going on, you can flip it back so it goes back to the previous version again. So you can always roll it back very, very quickly. And then when you see that you have a stable solution or a patch that has been upgraded, nobody has an issue anymore, and everybody's on the new version, safe and sound, you remove the old code. So it takes a bit longer to remove old code and like deprecate it, but it's a very stable way to make sure that you can always roll back if something unforeseen happens. So what I want you to take away from this is that there is a lot of ways that the large companies and I work for a company that is at the same sort of size as some of these companies, and I have in the past as well. So when you work at that sort of size, it's very difficult for you to cover all the ways that you can do testing. I've just given you a few examples. The normal way is that it's very difficult for you to do those standard manual testing or end-to-end testing. Is very expensive in these larger systems. So many times you invest in making sure that you have really good unit test coverage, really good testing bubbles or contract testing, something like that, so that each piece is very well tested, because testing the whole thing as a gigantic structure is extremely complicated and very difficult many times. But when you are going to do that sort of thing, investing in feature flagging and synthetic logging or something where you simulate a user and sort of observe the interactions, or maybe you do UI testing on some portion of the application and so forth, these are very favored methods of doing so. It's just that you have to sort of the testing pyramid is a very good thing to know about here, because the ideal case is to stick with the unit test and not go too high up on the pyramid, because it gets very expensive and very difficult to maintain large suites of end-to-end tests in a very, very big distributed system. That's why I'm a big fan of feature flagging and canary releases or blue-green type of things, because it's sort of like dipping your toe in. You accept that maybe one or two people will have an error here, and just one error, and then you immediately roll back when you see that happens, rather than trying to make every release completely flawless, because the reality is that it's impossible. You might be very good at it, but you are going to get issues in production. So accounting for that immediately before you even try to do anything else, I think, is a very good and sustainable way of working. Have a great day.